Hi, in this video we talk about binomial theorem. Binomial theorem can be done in two ways. The first one is if you have the index as positive and integer. Index means actually the power. And the second way is that for any kind of index, you can have binomial theorem. Now, before going into details about these two ways, let us go for these examples. If you have your expression with only one term inside, then you say that it is a monomial. For example, the 16 is a monomial, 4x is a monomial. Now here you see that 4 is a constant and x is a variable, but these are in multiplied form, so there is a dot operator between these two. So this will be treated as a single term where there are two factors. 4 is one factor and x is another factor. Here also, this one is a single term and this one is also a single term. When the expression is having two terms, then you call it binomial. For example, this x and y, there are two terms separated by a plus sign. You have this p and q separated by a minus sign. That means whenever two terms are there with plus and minus as a separator, then you say that is a binomial expression. Here also you go and here also. Now if you have three terms inside, then you say that is a trinomial. For example, this x is a term, 2y is another term, and 3z is another term. So there are three terms separated by a plus sign as well as a minus sign. So this is a trinomial. This one also is a trinomial, and this one also is a trinomial. Now, if you have four or more terms, then you say it's a multinomial. For example, this expression is having four terms and is a multinomial. Also, this one is having five terms. It is also called multinomial. Clear? Now let us go with this formula you have learned in your school days. A plus b whole square equal to a square plus 2ab plus b square. Now how you got it? You go like this, a plus b times a plus b. That means this a and this a multiplied, so becomes a square. Then this a and this b will give you ab. This b, this a will give you another ab, and this b will give you b square. So it becomes like this. So what you have done is that a plus b whole square has been expanded to a square plus 2ab plus b square. Now if I change this power, this 2 to 3, then it will have another expression like this, or another expansion. If I change it to 4, then it will give you another expansion. Now the question is there any hidden pattern inside that this system is actually following? Let us see. The first step is that we will involve both the variables in all these terms in the expansion. So this first term, b is missing. The second term, both a and b is there. That's all right. But in the third term, you see b square is there. That means a is missing. So we will try to involve this a and b in all those terms. This is the first step, right? So it goes like this. In place of a square, you can definitely write a square dot b is raised to 0, because b raised to 0 is 1. See the second one, a raised to 1, b raised to 1, that is all right. But in the third term, a is missing, so you can write a raised to 0 dot b square. So in all the terms, both the variables a and b are involved. Clear? Now we will deal with the coefficients. In the first term, the coefficient is 1. The second term is having coefficient 2, and the third term is also having coefficient 1. Now, is there any pattern inside for getting these coefficients? Let's see. We can replace the first one here with 2c0. That means 2 choose 0. This is the expression of combination. I have already explained permutation and combination in details in the previous video. So this is 2c0, which will give you 1. So in place of 1, you can write 2c0. Now come to the second term. there is 2 here. So this 2 can be replaced with 2c1 because 2c1 will give you 2. And here also 1 is there. So in place of 1, now we can write 2c2 because 2c2 will also give you 1. Now do you notice one thing? Start with the combination. See, NCR. This is the form. Now it is taking the value of n every time from this power. So here is 2, here is 2, and here is 2. That's fine. Now here you see that r is 0. Here r is 1 and here r is 2. That means the value of r is starting from 0 and moving towards 2. Now we go with a. A starts from 2, the given power here. Then in the second term it goes down to 1 and in the third term it goes down to 0. So a starts with 2, then 1, then 0. And look at b. B starts from 0, then goes to 1, then goes to 2. That means b starts from 0, then goes to 1, then goes to 2. So there is a pattern inside that will give you the binomial coefficients and the powers of a. There is the first term inside the given binomial form and the powers of b, that is the second term in the given binomial form. Now let us check with another formula you know, a plus b whole cube. It is a cube plus 3a square b plus 3ab square plus b cube. Now involve all the variables. In the first term, a cube is there and you can obviously write b raised to 0. Here both the variables are involved, so you write a raised to 2 and b raised to 1. Here in the third term, a raised to 1 b square, and in the fourth term bq is there and in place of 1 you can write a raised to 0. Now I go with the coefficients. In place of 1 here we can write 3c0. In place of 3 we can write 3c1, then we can write 3c2, and then we can write 3c3. This kind of expansion is actually following a pattern, and that pattern actually will give you the expansion based on the power here we have used. So what is your binomial theorem? Of course, it's a statement that will show you the way in which you will expand the given binomial. So whatever may be the members here or the terms here inside, and whatever may be the power here, it may be 2, 3, 4, 5 like that. You just follow the pattern and get the result over there without multiplying each term. So if we generalize, now what we got, the power is n, and the first term is a, the second term is b. Then of course it's nc0, a raised to n, b raised to 0. You see here, a starts from n and goes to a 0, right? That means this one is n equal to 2. So a starts from 2, then goes to 1, then goes to 0. So that's why a starts from n, then it goes down by 1, that is n minus 1. Then it further goes down by 1, that is n minus 2, and it ultimately reaches 0. And in case of b here, it starts from 0 and goes up to n. So b starts from 0 here, then goes to 1, then goes to 2, and then goes up to n. And in case of binomial coefficients, you have this n as a static thing. It is not changing actually. But the r is actually starting from 0 just like b, and it is moving up to n here. So if you squeeze this term, this whole expression, then you have this summation r equal to 0 to n. So NCR, a raised to n minus r and b raised to r. Now one condition is here, your n, that is the power or the exponent, must be a positive integer, right? So it must be 1 or 2 or 3 or 4 or 5 like that. So finally we summarize what we got. These are the binomial coefficients, and we follow exponent of a. It follows like this, n minus r in case of NCR, and we follow b, then we get that value as r only. And if you add the exponents of a and b, then you get n, right? So you see in the previous slide, suppose this one is 1 and this one is 1, this 1 plus 1 gives you 2, this one is 0, this one is 2, it will give you 2. If you add these two also, you will get 2. So every time in each term, you add the powers or the exponents of a and b, you will get the n as the added value, okay? And the total terms after expansion, this is quite interesting, is n plus 1. See here, you have the exponent as 2 here. So you have 3 terms, right? So this one is the first term, this one is the second term, and this one is the third term. If you have 3 here, then you have 4 terms in the expansion. This is the first term, this is the second term, third and fourth. So if you have the power as n, then you will have n plus 1 terms. It's quite obvious because you see that b is moving from 0 to n. But definitely 0 to n means there are n plus 1 terms. It's clean and clear. Now this one you must be very careful about. This is a positive integer, okay? Now this formula applies only with positive integer, and if it goes with negative, that means say a plus b raised to minus 4, or n is rational, that means a plus b with raised to 2 by 3, then this machine will fail. So there is another technique we can handle this kind of naughty things. And before learning that technique, let us do with some examples what we have learned so far. Let us go with an example based on what we have learned so far. A plus 1 by a raised to 4. That means n is 4. And the first term a is a. And the second term we refer as b. Here b is actually 1 by a. Okay? Let us write the formula first. Summation of r equal to 0 to n, ncr, a raised to n minus r, b raised to r. So when r is 0, we have nc 0. So n is 4 here, so 4c 0. Then a raised to n minus r, that means n minus 0 now. So 4 minus 0 gives you 4. And here b raised to r, that means 1 by a raised to 0. The second term, when r goes to 1, so 4c1, a raised to n minus r, that is n minus 1, that is 3. And this one, b is raised to 1. So when r is 2, 4c2, a raised to 2, 1 by a raised to 2, like that. And here r is 4. So we stop here because r has already reached 4, also b reached 4, and a has reached to 0, right? Now if you evaluate, the first term will be simply a raised to 4 because this is 1 and this is also 1. The second one is 4c1. 4c1 will give you 4, and this a cube is here, and 1 by a is here. So this is the second term. This is the third term. 4c2 will give you 6, and a square, and 1 by a whole square. And then you have this term, 4c3, it will give you 4, and then a, and 1 by a whole cube. And this 4c4 will give you 1, and this a0 will also give you 1. So you are with 1 by a raised to 4 only. So if you simplify, you get this expansion. So a plus 1 by a, these are the two terms, raised to 4, this can be expanded to this. Now you arrange the value of a and you just plug the value of a inside this expression and you will get the result. We go with another example where we have minus inside, okay? So what we can do, we can go like this. Your b is actually minus 4. b is actually minus 4 and a is there as it is. So r equal to 0, r1, r2, r3 and r4. And we have this b here inside. So this b, that is minus 4 raised to 0, this will give you 1, and 4 to 0 will also give you 1. So the first term it will be a raised to 4 plus like that. So I leave it to you to complete this thing, and we go for binomial theorem for any index. Now we got this expansion with n equal to a positive integer. So nc 0 up to ncn, and b starts from 0 up to n, and a starts from n and it goes up to 0. That's all right. Now the question is, what if we have this kind of expression further, that is beyond n? So you say that up to n it was all right, but if I go for nc n plus 1 and a from 0 goes to minus 1, b raised to n will definitely go to b raised to n plus 1. We expand further, we have another term. So in that case, nc n plus 2, a goes to minus 2 and b raised to n plus 2. Now if I forcefully write these expressions, does it matter? No. Why? Because beyond the value of n, where the r moves, all these expressions are zeros. That means this expression, this binomial coefficient is 0, this binomial coefficient is 0. Because when NCR is there, where r is greater than n, then this binomial coefficient will give you 0. So if you continue with the terms beyond n, all these terms will be equal to 0. Clear? Now say n is equal to minus 3. Then we have a plus b raised to minus 3. This one is n. So you write like this, as it is given in the expansion, that NCR, that means NC0, minus 3C0, a raised to n minus 0, minus 3 minus 0, and b raised to 0. Okay, so this is all right. Next, minus 3C1, a raised to minus 3 minus 1 now, and b raised to 1. In the third term, minus 3C2, a raised to minus 3 minus 2 now, and b raised to 2. You go on like this. Now you simplify, then minus 3C0, a raised to 3, b raised to 0, then a raised to minus 4, a raised to minus 5, and b 1, then b 2. Now you notice here one thing. You are supposed to move a towards 0 and b towards n. But what is happening here? If I go like this, this one is the positive side, this one is the negative side, this one is 0, 1, 2, 3, 4 like this. This is minus 1, minus 2, minus 3, and minus 4. So your n is standing over here, and you start a with a minus 3, then it should move towards 0. But what is happening here, you see, first term a is minus 3, the second term a is minus 4. That means a is moving this side instead of moving towards 0. Whereas b starts from 0 and then it moves to 1, then it moves to 2. That is positive side. That means b is moving towards this side. That means a should move towards 0, but it is moving away from 0. And b should move towards minus 3, but it is moving on the other side. This indicates that this expansion will never terminate. That means this expression will not converge. Now what we can do? Now let us go with this thing. I have to clean it first a little bit. 3 raised to 0, that means 1. 3 raised to 1 is 3. Then this one is 9 and this one is 27. That means if you have an integer that is 3 and you increase the exponent like this from 0 to 1, then 2, then 3, then the end result is also increasing, isn't it? But if you see here, this is a fraction where the numerator is less than the denominator. Now you have this power as 0, it gives you 1. You make the power 0 to 1, it gives you 0.75. And if you increase the power from 1 to 2, it goes to 0.56. And from 2 to 3, it gives you 0.42. That means from 1 it is going down to 0.75, and further you increase the power, the net result is going down further like this. That means you keep increasing the power. That means what the B is doing here, it is starting from 0 and moving towards 1, then moving towards 2 like that. And if you have your B as a fraction like this, whose numerator is less than the denominator, then definitely this B will go down as the power goes on increasing, right? And as B goes down, then it will pull down the whole term downwards. So as you go on increasing the terms, the net value of those terms goes down. Now how far it will go down? The values will go down towards 0, but it will not be exactly 0. The rate of change of the numerator is lesser than the rate of change of the denominator. That means the divisor, right? So when the divisor goes higher than the dividend, then the quotient automatically goes down, isn't it? So this technique we have to apply to get an approximation of the values of this kind of expansion. That means we have to add more and more terms like this until it gets very near to 0, right? So in this technique, we will not be having the actual value or the exact value, but we will have a good approximation. This is the notation you will find in textbooks and other resources, that mod B less than 1. That means B will be in the form of this kind of fraction, 1 by 11 say. These are examples I have given, 4 by 5, 3 by 20, 7 by 13 like that, and all are positive. You see the absolute value of B less than 1. So if it is less than 1, that means B may be minus 2, 3. This is also less than 1, definitely, but they are asking you to take the absolute value, right? So you take the absolute value of this minus 2 by 3 and you will get 2 by 3. That is actually you are having the expressions, the fractions actually in positive form always, right? So if you can manage to get the B in this form so that the absolute value of B is less than 1, then definitely you will find the solution like this kind of approximation, okay? So you can write the B as this also. It is between minus 1 and 1. Of course, minus 1 and 1, these are not included, where B is in the form x by y, where x is less than y. We go for another technique. It will be like this. Make the first component as 1, that is A is becoming 1, and the B is in this x by y form, okay? So B will be in x by y form. So if you have this, then you can simply have this kind of expansion, that nc0. Simply we have used this expansion before. The same expansion we have written here, nc0, 1 raised to n, b raised to 0. That means 1, that is A is starting from n. A goes down by 1, A goes down by 2 like that, and B starts from 0, then 1, then 2, and this one is nc0, nc1, nc2. Just the same thing we have learned so far, but here we can get a simplification of this term, that nc0 b raised to 0, because 1 raised to n, 1 raised to n minus 1, these terms are actually 1, so we can omit it and we can have this kind of simpler form. Of course, remember it, that absolute value of b will be less than 1. That means it is in the form x by y, where x is less than y. Just remember this thing, okay? If you can manage to get the expression like this, then you can have this simple expression also. See here, the first we have to do is that, since we are talking about the second technique, there is the approximation technique that will work with any index, then let us check whether it is working with the positive index, and then we will go for the negative index as well as the rational index, okay? So let us see how it works. So we have got this 1 plus b raised to n. Just now we have discussed that make this a as 1 and the b is in x by y form, x less than y. Okay, this is your expansion, that's a plus b whole cube. Now you have to convert this a plus b form with this form, right? How you can do? Pull out a so that it becomes a cube times 1 plus b by a. I hope it's clear to you actually how it comes out like this. Okay, I will do it here. A plus B. If you pull out A, then what you will get? 1 plus B by A, isn't it? Now, if it is whole cube, then definitely this will be like this. And now keep this A cube as it is, and you expand this thing to this thing by following this formula. That means here 1 is 1, that is all right. But the B part, that means x by y is your B by A. This one is the x by y part, okay? And then you have A cube, this becomes 1, and this 3c1 becomes 3 B by A, then 3c2 will give you 3 and B by A whole square, and this 3c3 will give you 1, so it is only B by A whole cube doing here and plus dot dot dot, okay? Now you see here, you simplify this, that means you push this A cube inside now, so this first term becomes A cube, the second term becomes 3A cube B by A, the third term is this, and the fourth term is this. And when you go like this, that A cube, then you simplify this and you will get this A cube plus 3A square B plus 3AB square plus B cube. And if you continue with this thing as we have shown before, these will be all zeros. So the second technique actually is also working with positive integral index, isn't it? Now we will check whether it is working with negative index and with rational index, okay? See here, minus 3 is a negative index, and here is A and the B is 2x, right? So we have 3 plus 2x raised to minus 3. Now what will you pull out? One more thing. I will go back to the previous slide once more. Yes, here it is. We assume here that this B by A is following the format of this x plus x by y, where x is less than y, isn't it? Now if it happens that B is greater than A, right? Suppose B is 4 and A is 3, then how will you manage? The point is that to make this second term in the form of x by y, x less than y, you pull the bigger term outside. That means, what I want to say is that, you see here, A plus B, and suppose A is 4, B is 3. Then you pull the bigger term out, right? So you go like this, 1 plus B, B by A. You see, 1 plus 3 by 4, isn't it? Now, if it goes like this, that this one is 3 and this one is 4, then if you pull out A, then it will be 4 by 3, isn't it? So it will be wrong. So this time, when A is 3 and B is 4, that is B is larger than A, then you pull the larger one out. Now you go like this, A by B. So it becomes 3 by 4 again. So you always remember that the term with the bigger value, you take that value out of this bracket. Then only your B will be in mod form less than 1. Now we come back to here. 3 has been pulled out of the system. Assuming that 2x is less than 3, okay? This is an assumption. We do not know actually the value of x. So if it goes like that, that 2x is less than 3, then we have to deal with in a different way. That means the opposite one, the larger one will be pulled out, okay? So here we have this assumption that 2x is less than 3, then we go like this. The 3 is pulled out, then 1 plus 2 by 2x by 3. And if you separate these things, then the power minus 3 goes with 3 here, and this power minus 3 goes with the rest of the symbol, right? So this is your expansion. Now you apply this same formula, you keep this 3 minus 3 as it is, and you expand this thing that this one is A and this one is x by y, where x is less than y. So you expand this thing, and I will stop here and I will ask you to complete this numerical, okay? Next we go for a rational exponent like this, that 2 by 3 is your exponent here, and the same technique you apply. Here minus is there, so minus 2x will be your B, so it will become like this, 5 plus minus 2x raised to 2 by 3. Now if you pull out B, expecting that minus 2x is less than 5, then 5 raised to 2 by 3 will be here, and the rest of the portion will be like this. Okay, and you expand this thing, 5 raised to 2 by 3, and your n is here 2 by 3, right? So n is 2 by 3. So this one is nc0, b raised to 0, then nc1, b raised to 1, nc2, like this. And here also I will ask you to complete this numerical, mentioning that absolute of 2x by 3 is less than 1. So that is all with binomial theorem, and this will be very much useful in prediction. So if you have any kind of question, you can write in the comment section. That's all in this video.